Okay, it's time. Strategic Management of Information Technology. Here we go. Okay, so I have two new items that I put out on bhacker.com. Hopefully you've got connected so you can see. Oh, good. Very good. The midterm and the CSLO, so I want to cover that. And then I have a new lecture on cloud computing that we're going to start today as well. We're not going to get through all of it, but we'll get through most of it. Well, maybe just an orientation to it at this point. But the most important thing are these two items here. The midterm is going to be due in approximately a month. So it's April 17th, I believe, is the due date on that, which is a Sunday night. So it's right after taxes are due, right at the weekend there. And the CSLO essay will be due at the end of the term, so at the very last day of the term, which is going to be the last weekend in April, or the first week in May. Depending upon when we have it scheduled. We'll probably have the final exam schedule out, probably in the next week or so. That's what I'm thinking. So let me talk about the midterm. The midterm is worth 20 points. And there are 10 questions, and you answer 10 questions. So it's pretty easy in terms of understanding what you're supposed to do for it. What you're doing is you're answering in the following 10 questions in a paragraph or two for each one of the questions. And there's many different ways of answering the questions. There's no right or wrong answer. It's depending upon whether your answer is appropriate. As an example, I'll look at the first one here. And the first question says, what is meant by IT information technology and IS information systems? You can probably write more than like a book on this, probably. You can probably write an entire book on it. But you want to basically define information technology, define information systems, and then explain how these two terms work together, how they differ. So when I say paragraph or less, I'm looking at maybe 100 words, 150 words. The average paragraph is 100 words. So about 5 or 6 sentences, 7 sentences, something of that nature. So don't get too carried away. I don't want you to write like an entire page on each one of them. A couple of the other ones are a little bit more specific, describing 4 benefits that the use of information technology has for a business, describing how IT can hurt or damage some aspects of a business, explain how the Porter's five forces model can be used for strategic management, and then looking at, here we got supply chain, customer relationship management, enterprise resource management. If you notice, all 10 questions kind of start at the beginning of the course and go through all the way up into and including the last kind of concepts that we've been talking about in terms of SAP, which was covered last week, and then the use of databases and database technologies. And today we're talking about the use of cloud computing and service-oriented computing in terms of information technology, which is not on the midterm. Because everything came up to essentially last week. And if you have questions about any of the items in this list, you can always send me an email message and I can answer them for you. But it's fairly straightforward. As all the midterms I put together this term, this one's probably the most straightforward and easiest one to kind of follow along with. Questions on the midterm? No? Okay, good. Let me close this for a second. The CSLO essay. I know you were here last term. Were you here last term? No, this is your first term? Alright, so if your first term, you don't have to worry about it because you don't remember any nightmares from previous CSLO essays that we had to do for the school. If you are returning, we have a brand new format. So you don't have to worry about the CSLO essay. Alright, so what are we doing here? The CSLO essay is a writing assignment. And it's graded primarily on your writing abilities. And it is not a regurgitation of every one of the student learning outcomes of the previous, like that were listed in the syllabus. There was 5 of them, and you had to answer like 5 different ways on each one of them. Not like that at all. Nothing at all. It's worth 20 points. You're selecting one of the following essay topics. Do not answer them all. There are 5 different topics, so you select one. And for the one you've selected, you're writing a 3 to 5 page double-space essay. So 3 pages is really 1.5 single space. So this is a lot more volume for answering the question than the midterm. This one's not due until the very last day of class. And what you're doing is you're putting together an essay. You're including 3 reference citations, which means I want you to actually do some research. You're putting together an academic quality paper with references, with using a writing style like APA or MLA or Little Brown Book or any one of the style formats you might be familiar with. If you're not familiar with an essay style at all, and you're a graduate student, I would be surprised. However, and that might be the case if you've been studying technology, so I would look up the APA. A is an apple, P is in Paul, A is an apple. You can get information at www.apa.org. It's American Psychological Association format, but it's used a lot in liberal arts and in business and in all sorts of different subjects. What I want is your best work, essentially. I want you to put a title page on there, some writing headers, some page numbers, double space it, have 1.5-inch margins or so. Make it look presentable like an official academic paper. Add 3 reference citations, which means you're going to have a reference list at the end with proper formatted. I don't want cut and pasted URLs, and I don't want you to cut and paste information off of the internet and put it in the paper. That's not going to work either. The main objective of the essay is to show your own writing, and cannot contain portions of cut and pasted information off of the internet or other sources. Don't copy a book in there. It's not like high school where you're doing a book report or something and you're just copying word for word out of the source. Because here's the way the grading is going to work. All of these papers are going to be processed through Turnitin.com and also through plagiarism detection tools such as internet cross-checking and stuff. And if the paper ends up being plagiarized and not your own work, you're going to receive 0 credit on it. If you receive 0 credit on it, it cannot be made up. So it's a pass or fail kind of thing. Either you turned it in and it was good, it was your own work, and I shouldn't say it's a pass or fail grading, it isn't, but if you turn it in and it's not your own work, you failed it, essentially. You're going to get 0 points on it. You don't have an opportunity to do it again. The assignment's worth 20 points, so if it's plagiarized, you're going to get a B- in the course automatically. That would be 80 out of a 100-point scale. It's 20%. So you're looking at an 80% in the course. So that grade cannot be changed or altered. It's going to be essentially the grade, the highest grade actually you're going to be able to get. So it means you're probably not going to want to plagiarize it. And you're going to basically have an opportunity to practice your professional academic paper writing in English, which means it's as a graduate student, you probably need some practice writing, and writing is going to help you, especially in English. So it's not a bad idea to work on it and to kind of represent your own work. And the questions are a little bit more trickier than the midterm because they're meant to be, you need to write like 3 to 5 pages on it, so it's going to be a little bit more entailed. And here are the topics that you select one of. And the first one is, and I'm going to go through the topics and kind of give you some ideas to give you a better direction of how to approach this. The first one says, describe how using an IT strategic management process. And you see, you can see on the slide too, I've kind of changed the font to highlight the focus of the question. Because some of the questions might sound similar, however, they're all different. Okay, so this is using an IT strategic management process and how it can help deliver value through IT leadership, support your theories and concepts with examples and case studies, try to provide some real-world examples to demonstrate your points. So if you're finding reference material, you might want to research companies, and you can use companies as your reference citations, either company manuals, company corporate websites. So you're not excluded from using non-academic sources as long as they're relevant towards what you're writing about. Because in some of the other classes, I'm specifically asking for academic references, like journal articles, books, papers, and periodicals and things. Here, what I'm looking for is primarily case studies, real-world business examples, something that you're going to use as a demonstrating your point. So that doesn't mean that your references can't come from journal articles and stuff, but most likely, you probably could search through business journals and come up with case studies and information because it's part research, part writing in terms of what you're accomplishing here. Okay, so and stop me as I go through these if you have any questions about what you can write about for each one of them. In the second one, we're looking at competitive advantages. So provide an overview of the changing nature of competitive business environment. What does it mean to compete? So what are some of the current ways to use IET to gain competitive advantages? And you'll notice like all of these have like multiple questions in them. If you don't like one of the questions, you may not necessarily have to answer what does it mean to compete, as an example. I mean, you might just have one sentence that answers that. I don't want you to take and outline out all the questions. I've seen this before, actually. Outline all the questions and then give me answers to them. You're writing an essay, so you're putting together a formal thought about, and you're addressing these issues or questions. So the third one is on different schools of thought when it comes to IT strategy formation. And this is the strategy formation that I'm concerned with. The second one was the competitive advantage. The third one is associated with issues that are associated with effective IT implementation. So the fourth one is focusing on issues. The fifth one is focusing on transforming the business via IT with dynamic capabilities. So how to transform a business to create a new competitive advantage, to streamline a process, to add a new product or service to a business. And you can, in this particular one, all of them come out, so describe the business and your proposed transformation plan. I want you to pick a business, an existing business, and suggest something. In fact, number 5, I almost would say would be my pick because it would be the most interesting in terms of a case study. So you're picking an existing business and you're transforming it using IT to add some benefit to it. More practical, hands-on, I think, actually, for number 5. And, the other ones are not bad picks either. Depends on what your interest and your focus is, but only pick one and only address one of the, you're only writing one essay for this, you're not writing 5. I have had some students already send me email messages going, that's a lot of writing, 3 to 5 pages for each question? I'm like, no, you just pick one question. Did you have a question? Yes. One of these. You only have one CSLO essay for the entire course. And I know some other courses have like weekly CSLO stuff. There's only one essay. It's 3 to 5 pages, and it's due at the very last day of the course. Actually, it's due at the day of the final exam week. We haven't set the exact date yet. So, good question, however. Are they still doing it? Are they still doing this at one a week? Same format as last term? Answering how do you feel about strategic IT? But the similar format though. Do they have other assignments? Really? Along with the 4 or 5s. Wow, that's a lot of writing. Oh, for this class you don't have to do that. You have to write one essay. 3 to 5. Yeah, collectively. Yeah. I don't know why they like to spread it out. Other than maybe they just want to collect it on the way. Perhaps. Everyone has their own style. Questions on the CSLO essay? Any more questions? Nope. Okay, good. Moving right along. See, we went through that faster than I thought. All right. Let's talk about cloud computing. That is really the focus of today. And as I mentioned last week, I'm bringing in this new lecture. It's lecture number 17 on the website. It was added to the bottom of the list. So it wasn't there last week if you looked at it. But it should be available now, hopefully. An introduction and overview of cloud computing, because as I've actually had a couple people request it, not from this class but from other classes, which is kind of interesting. And I thought, well, it's kind of a relevant topic that I didn't originally add in terms of my strategic management of information technology, but this is very relevant in terms of what it's covering. And you just missed everything on the, you guys just missed everything on the midterm and the CSLO. But you can pick it up. Watch the video. All right, so what is cloud computing? And that's a lot of writing. Actually, it shows up pretty nicely because of the black and white contrast on the slide. Cloud computing is a general term. In fact, I would almost call it an overused term to describe a new class of networking computing. It takes place over the internet. Basically, it's a step up from utility computing. People are, what are utility computing? Well, those would be services or service-oriented computing that's done entirely over the internet, that You don't have to install an application. Instead, the application is on the internet. And you can kind of think of Gmail sort of like that. It's a utility computing email application because you're going to a web interface, or you're using the web interface, accessing the information, putting it on your local computer, caching it, synchronizing it, or deleting what's on the internet and downloading it to your local computer when you use a program like Mozilla or something like that, or an email client on your computer. So you have some options with that. So it's not fully utility. It's really an email kind of oriented service. So in other words, you might also consider this as being a collection or group of integrated and network hardware, software, internet infrastructure. You might consider it a platform. In fact, most of the advertisements and stuff that are out right now in terms of what cloud computing is, you always hear to the cloud, for the movies and stuff. And really, what they're talking about or promoting is this platform. And it's this computing platform that is more than just a network, and it's more than just the internet, because you're sharing information, you're uploading simultaneously while you're recording. So let's say you're using one of these Uverse, or not Uverse, there's many different new products out on the market right now for sharing stuff. The concept being you have it with you everywhere. So that couple that's at the airport and they go to the cloud because their flight was delayed so that they can watch movies that they've recorded on their home. It's the concept, what they're trying to tell you. In fact, the commercial, I believe, is lost on a lot of people because they have no idea what this cloud is. Why are you going to the cloud? What is this cloud? The concept being they carry it with them because it's not stored on their local computer. It's not stored on anything that they particularly own. It's a service that's stored on a shared network drive that's accessible through the internet that is housing your content, using your content. It was kind of like Gmail going back to it, if you think about it. The concept being, it's out there, so you can go to any computer or a coffee shop or whatever and check your Gmail. It's kind of like the way Yahoo was working, Yahoo email and stuff like that. So it's really a utility computing. Think about it, a utility of storing email, storing files, storing pictures. People are loading pictures on cloud space, and you might call it a shared network drive instead of cloud. And videos that are recording, all sorts of different content. So using the internet for communication and to transport provides hardware, software, networking services to clients. Platforms hide the complexities and the details underlying the infrastructure for the users and the applications by providing very simple graphical user interfaces or API, application programming interfaces, that are being used by third-party vendors. So your TV system, that's your DVR, you don't have to select the location or the title. The program is actually creating all that information for you, getting rid of all the details. It makes it easier for non-technical people to use. Translate all this into technical stuff. The cloud's been around for years. Nothing more than a shared network drive. Okay, a little bit more. It's more application-oriented now. But anyone who's familiar with Linux or Unix or has worked with servers, client-server environment, or networking, or even distributed computing, it's the same concept packaged differently for consumer users, in essence. And I'm kind of making it trivial by describing it that way. It's a little bit more complex than that, a little bit more entailed. However, it's the same concept over again. So in addition, the platform provides on-demand services that are always on, anywhere, anytime, any place. So you don't have to actually manually connect to a drive, let's say. Like before we had cloud, before it became a consumer product, when it's back as a technical user who was using it, you had to have like an FTP program or a shell client, connect to it, load your stuff, use your stuff. It was more manual. It wasn't quite an instant, it's available on right now kind of thing. It wasn't configured. There was no graphic user interface to it. There was no controller application that's running it. You had to do it all yourself. Now it's all application oriented. So you can buy a program, install it on your computer, and it connects automatically to your space, your internet space, your cloud, your shared drive, that is automatically going to sync everything for you, configure your application to work with it instantly. So the user doesn't have to do anything. And you could possibly maybe at this point kind of imagine, well, what sounds all good and everything, but what could possibly go wrong? Well, it relies upon internet connectivity. So you're assuming you have internet connectivity when you're using your space, your cloud, and you have a strong speed. So this all came about because we have 3G, 4G networks for cellular service, so we can connect mobile devices to the cloud. We have higher speed. Everybody's got DSL in their houses, or they have cable modem or something that's of higher bandwidth. It doesn't work with dial-up. You can't use this concept with a dial-up or with a slow connection or with an unreliable connection. So you think about it and go, well, unreliable connection, how widespread can this cloud concept go? It's not going to reach every part of the country, every part of the world, especially in places where they have unreliable connections or slow connections, and things like the weather and things get in the way. So, the growth of it has some problems that need to be dealt with in terms of connectivity and things like that. The hardware and the software services are available to the general public as well, enterprise, corporations, business markets. Well, that I can, I'm giving you just an overview right now, but I can already see security might be an issue with the cloud. So your pictures that you uploaded to your cloud space are available to everybody in the world. So you have no privacy, essentially. And but you think about it, and people don't really have any privacy anymore. Anyway, if you don't put your pictures on this cloud, you might put it in Facebook. You might put it in MySpace or somewhere else where it's shared. Yes? Say another? Salesforce.com has a huge cloud application. Yeah. It is a really good upfront business example of it. Yeah. Hardly anyone in the market is really familiar with it because it's just brand new, out within the last couple of years, and it's still sort of in beta form. I've got some other stuff in the slides that I'm going to show you, as well as some other examples applied towards business. But if you don't understand the concept, it's really hard to kind of see how it would work with an application. Yes? By the cloud, by the platform. And unfortunately, it's not a strong feature at this point. Which is why a lot of people aren't using it. It's slowing the development down significantly, because why are you going to put your business... so originally, and this kind of ties in with what I was talking about, originally, it's consumer use, right? Put your pictures, your videos up. Okay, what if a business starts using this? They're going to have their proprietary projects that they're working on, their sales contacts, all of their information out there, and you've got it out there, shareable, and it's not in your control or your possession, and it's on a lot of different servers and things, and so it's spread out all over the place. You lose track of it, you lose control over it, and you're relying upon somebody else to provide you with security. It's kind of like how people with Facebook, every time there's a new feature out, then they go, oh, there was a security leak. All of your Facebook information was all leaked all over the place now, and people, what? I have my pictures of my golf trip online, Everybody's, we don't care about that, but what if it's your financial documents, or it's your accounting, or it's something that's really yours as a business? You can't afford to make that kind of a risk, that kind of a mistake, to expose yourself to that risk, which is why there's a lot of hesitation, actually. There's companies like Salesforce.com that provide a service that was internet-based. They've moved it over to cloud kind of concept, because it makes, and here's another advantage of the cloud, it makes efficient use of space and hardware and services, and it blends the application with the storage and with the information. So you're not going out to the internet with an HTTP type of interface, and you're not using old-fashioned browser kind of technology where you're uploading and you're downloading and you're transmitting data back and forth. Instead, with the cloud concept, you've got a middleware platform. You have a system that's running on many different computers, sharing data across the systems, and it's more of a network versus a upload-download connectivity. So when you go to a cloud, as an example, you're going to many different websites or many different web servers that are all part of this cloud. And it kind of got the name because you know what a cloud is. It spreads out over a big geographical region, right? And it covers everything underneath it. So a multimedia application cloud for home computer users to put their videos on. You got this computer, this guy, this guy, this guy, this guy, all of these separate kind of video things, but you can manage it and house it all together, which creates that sharing environment. So theoretically, there's no reason why you couldn't watch somebody else's recorded showing, or because you have access to it. It's all at the same location. It's all in the same cloud, all in the same environment network. So it provides for future growth in internet type of applications and services, such as transformation of the Salesforce.com, transformation of a lot of different services. All right. So in summary, the cloud computing. This is just the kind of the definition summary. It's an umbrella term. It used to refer to internet-based development services, and often overused. It's like how object-oriented this, object-oriented that. Now everything is cloud this, cloud to the cloud. What in the world does that mean? To the object-oriented world. It's nothing to do. Cloud computing has nothing to do with object orientation, but as a word, it's often overused. The number of characteristics define the cloud data, the applications, the services, the infrastructure. And so what we have now here is a kind of a list of some characteristics. So it's remotely hosted. The services or the data are hosted on a remote, away from you infrastructure, which is great because you don't have to have the IT hardware. You can actually instantly have your business operate with this network without buying anything. You're just subscribing to a service, essentially. It's unambiguous. Services and data are available from anywhere, which means you relocate the business, you have a remote salespeople, which is kind of like what a Salesforce.com concept kind of works, because you don't have to be in a central location to use the service, and everyone out in the field can be essentially using the same things. And commodified, so you have a commodity of it. So the result is the utility computing model, similar to traditional models and utilities like gas and electricity. You pay for what you want, you pay for what you use. It's a commodity, like, getting electricity, subscribing to phone service. So you subscribe to applications this way. So there's talk actually about Microsoft putting Office in a cloud. And in fact, most of it's on a cloud already. And so you wouldn't go to the store and buy a Microsoft Office package and install it on your computer. Instead, you turn on your computer, click on an icon, it takes you out to a shared infrastructure, shared application service that gave you Office capabilities. So you can open up Word files, read Excel files. And the interesting concept is, in the old days, people used to pirate software. Pirate means copy it illegally. Or people used to take one version of Office and install it on 20 computers or something, either with a license or without. Problem is you got to go and you have to install it. So think about information technology and systems in a company. Every time you bring in a new computer, you got to configure it, like what we do at home. You got to put Word on it. You got to get it ready, download Mozilla, whatever it is you want to use for tools and services. You don't just turn on a brand new computer and it's already configured for you. In the future computing, you turn on a computer, it will already be configured for you because nothing is application software anymore. It's all going to be on a cloud. Technically, that's what they're. And that is not the case now. Not even the case in there 2 or 3 years from now. I would say probably 10 years from now. The style of computing is all going to be cloud network oriented. So your device is nothing more. In fact, this kind of goes back around and kind of think about cycles in the economy or an environment. This is how we started out with networking. We had dumb terminals, monitors and keyboards that connected to a network. In the old networking days. Now we've gone full circle, we're going back to it. Why do we need a huge processor? Why do we need, gigabytes of disk space and stuff? When we can share it, put it all in a network together, and you just turn your computer on, it's nothing more than a monitor and a keyboard, and you're connecting through an internet connection. If you think about it, a lot of appliances do this already. We have smartphones. Turn the smartphone on, and it's getting all of its data, everything from a network connection. Its signal. You send and receive information by your utility of using that smartphone. And so Why not make computers like this, essentially? So essentially the computer's going to be really cheap because it's not going to be anything. And what does that mean? Well, it means you can actually charge for the service. You can't use a cell phone in this country without paying for a service on it. In fact, if you don't have service, most likely the phone doesn't even turn on or work. You can use emergency dialing, but that's about it. So now companies like Microsoft can actually charge every user who's actually using Microsoft Office because they know in order for you to use it, you have to subscribe to their service. So you pay by usage, you pay by subscription, by person, by utility, instead of, here's a product, it's Office, buy it and put it on your computer. No, and then it's too easy to copy it, too easy to share it, and too easy not to stay up to date with it as well. So why in the world do we have all of these updates going on constantly? You turn your computer on and Microsoft update, this update, that update, because your software is constantly being updated so it matches the latest and greatest after you already installed it. Well, the cloud takes that away too. The cloud takes and makes it, if it's centrally located, and if it's out there on a network system that's shared by everybody, you only have one copy of it. You only update it one time. Everybody who connects to it gets the latest and greatest. So you don't necessarily have to worry about updates anymore either. So what you're looking at here is the infrastructure, platform, and then applications on top of it, which is kind of like how the cloud is actually kind of working. So we have the breadth and we have the niche in terms of the scale. This is commonly shared by everybody. It's the infrastructure. If you just came in late, we're talking about cloud computing today. And you missed everything about the midterm and the CSLO, but you can watch the video and catch up. So, all right, we have the platform that is installed on top of the infrastructure. And then we have the applications. So this is where we're going to get the Word, the Microsoft Office products, the Salesforce.com, and everything else that's loaded. The platform is going to change depending upon the application development. So this could be a television platform, it could be a business platform, it could be a social networking platform. So the way that we have applications working these days is we just have them on top of the infrastructure. The cloud puts in this platform in the middle, and this is what we're actually talking about in terms of the cloud, is this middleware. That's why sometimes they call it middleware, because it rides in between and puts it's like the glue that holds everything together, makes the application possible. And so here's our graphical picture then of, without the pyramid, that's our architecture looking here. We have service value networks. Service values are, let's say, our Salesforce.com, our customer relationship management utilities, our ERP programs, which is giving us the service, the utility. And this is where it kind of goes back to it's an upgraded utility platform. It's providing the tools and the services that we need for different functions. And we have Service 1, Service 2, Service 3, all connected together. So the services can actually run sort of like an ERP, where we have an enterprise that talks to each other, and our supply chain management knows about our purchasing engine and knows about our sales, knows about everything else, which means we can cross-relate information back and forth between different business functions, which provides even higher, better quality ERP kind of systems. In the middle here we have our platform as a service. So this would be our UVerse, or our middleware, and this is basically that triangle again, but it's showing you examples inside each one of the levels. So our platform here, you can't really read it. In fact, this is IT services in these boxes here, business services, community services. This is where I say one of these could be your cable television. So, as an example, when that couple was sitting in the airport, and, the flight was delayed, to the cloud, what they're doing is they're coming out and they're accessing through their network connection this little component here that happens to be their UVerse television. Or, in fact, that commercial's completely wasted on me because I have no idea what cable service they were actually advertising. Is it UVerse? I don't know. You see so many UVerse commercials. I have that word in my head, but I don't think it was that. I don't think it was AT&T. I think it was something else. So, who's advertising the cloud? That's the question of thought, and that's like failed marketing. When I can remember the cloud, but I can't remember what company, what product they're even trying to sell, what service that is, outside of the concept. And I think that, and actually a while ago, a couple months ago, there was another commercial out, and it was HP that was selling something. Again, I lost the product, but it was a cloud. Again, they were using the word cloud because they were trying to get people to put pictures on there, and they were uploading pictures to the cloud. And she had a digital camera, and she was this commercial was all about this woman who was taking her family pictures and putting them on the cloud. And I'm thinking, I don't even know. I think it was a camera advertisement. I'm not even quite sure what product was being sold. So, but I think most of the media was, so focused on, well, what is this cloud you're talking about? Because to educate the American public about the concept is a huge challenge. Because unlike other things like cell phone service, television service, internet service, we're all trained so far to know we have a service provider that gives us access to the internet. In fact, I would say about, not everybody, but majority of people are familiar with that concept right now. Take it and complicate it even further and take away the concept of the service provider and your applications that are running on your computer and put it all up at a different level, make it a network infrastructure, it confuses everybody. So, part of the big challenge of which slowing down this whole architecture is this complexity view from the consumer market. They don't understand what it is. They have no idea what it is. So they keep saying the word cloud all over the place, hoping that consumers are going to get a hint what this is all about. But still, I mentioned it the other day, actually, at a different school with the undergraduate students. And I must have explained it over and over again for maybe an hour. And still maybe 50% of the room actually got the concept. But these are undergraduate students who barely figured out the internet, who can't, are you at least getting the concept, hopefully, of what the thing, you guys are a little bit more intelligent than you. We're probably going to get the cloud concept, hopefully. If not, maybe you watch more television, I don't know. But anyway, so this is really what is new up here. We have the service value networks. Every time you subscribe to your ISP, every time you get Uverse television, you've got your service. And you don't pay your bill, they cut your service. You don't get your network. You don't get your television. Your TV doesn't get good reception after that. Your cell phone doesn't work. And we know about the infrastructure. This is what we've all tried to learn in the last 10 years, is what is this network? What is this internet? What are the services that are available on the internet? The new piece is this middle. This is the cloud, actually, this blue part in the middle. It's giving us our platform of services. So when we turn on our computer and we have access to Microsoft Access, or we have Microsoft Word or PowerPoint that's on the cloud in the future, we know we don't have an application that's installed on our computer. In fact, you guys are going to be probably the last generation who's familiar with the concept of installing applications on your computer. Why do we need to do that? We can just put it all on the cloud, sell it like a service, which is what's going on. So you go to this platform of services, the middleware, and you use what you used to use on your computer. What does that tell you? Well, it means you got to pay and pay and pay and pay. The pricing model as a business, much better, much better. As I mentioned before, you can't pirate software anymore. In that case, you have to pay every time you use it. You can strategize it out. You can have prepaid cloud computing. You can have monthly cloud computing. You can have, buy your own cloud. Your company could put your own cloud in there, which is what most companies are doing now to avoid security issues. So here's some different cloud computing layers. And this is going to step up the abstraction a bit more, but you guys can handle it because you understand what a cloud is at this point, hopefully. Application service. So it's abbreviated SaaS, and you'll never see the words actually spelled out. Instead, you'll see Google's SaaS. What in the world does that mean? Application service, so we have MS Live. That's what MS Live is all about, actually. In fact, Microsoft is trying to put that in. I shouldn't say the word hate, but I don't like MS Live, actually. I don't use it myself personally. Because when my network system goes down, so does my MS Live. I don't have anything on my computer. It's all on the cloud. which I'm personally going to be a late adopter to all this because I like control and I like security. I don't even have a Facebook account. That's how bad it is. I don't want to put pictures out there for people to see. I control the access to my data, which is contradictory to what this cloud is actually doing for me. They're sharing my data. They're getting my data. I don't have any more control over it. I can't delete it. When I delete it, I know it's gone off my computer. When it's on the cloud, I don't know what happens to it once you delete it. Does it really, and can you delete it once you put it up there? So things like Exchange Labs, IBM, Google Apps. Google Apps is all cloud oriented. In fact, Google's got one of the biggest clouds right now in terms of its application. Because Gmail, right there, as I mentioned earlier at the beginning when I started out this conversation. So, Quicken Online, yeah, Zoho, you know that, Cisco. So Salesforce.com also is a good example mentioned already in terms of the apps. Then we have the application platform. That's where we're getting the apps engines. In fact, that's what makes phones kind of interesting. The concept of the app on the phone is working with, because we don't have huge amounts of data that are being downloaded to the phone like we do a traditional application. It's short. In fact, if you've ever thought about the word application versus app is a smaller version of an application. It's truncated. So the app is all cloud-oriented because it's sharing a service. So pretty soon in these days, we'll have apps on our computers, no more applications, because we don't need that anymore. It's all on the cloud. But now I wonder what hard drive manufacturers are going to do, because we don't need 300 and 400 gig hard drives anymore either. So that'll be interesting to see if hard drives actually get smaller. My impression is they're probably going to stay about the same, and maybe the growth won't be as much because we don't need it anymore. It's kind of like what happened when we had floppy drives. We've had CD-ROM drives for a very long time, and DVDs for a very long time. We're not seeing anything, well, Blu-ray, but for quality. But we're not seeing, in terms of data storage, we're not seeing anything bigger than that. It kind of mellowed out a little bit because it became acceptable for modern-day applications. All right, so we have the application platform. That's where we have our apps, our Facebook, which is a good example of an application that runs on the cloud. We have our server platform, and then we have our storage platform. And our storage platform and our server platform are two separate concepts. Traditional old-style networking, they're the same, because all we have is storage that we're connecting with other storage. So we have a distributed Unix system, and it's all drives, and it's kind of the system. Now we have storage as a separate concept, and we have the system, the network as a separate concept. And this is where we get the EC2s, the slice hosts, the GoGrids, the grid computings. And the only way to kind of figure out what's new with that is to take a full class on server networking technology, modern day networking technologies / futuristic networking technologies. Our storage platform is going to be our Amazons, our Dells, our Apples that are going to have, like, for example, the MobileMe application, which runs on a shared server storage. So you've got a hard drive that looks like it's a local hard drive, but it really isn't. It's out there in the cloud, and you access it through your operating system, actually, which is kind of what they should do with cell phones. Why buy an 8 gig, a 16 gig, when you don't really need it? You got a connectivity anyway. Just put it out there on a shared storage drive and have all cell phones use it. But that might also cause some problems as well. So we have service layers. Let's talk about this for a second. So in terms of this application focus versus the infrastructure focus, we have different types of services that are looking at different markets or different purposes. So in terms of the services, what's meant by that is the complete business service, such as PayPal as an example. You guys are probably familiar with that. And Google Maps is another one you guys are probably familiar with. That give you, Google Maps works with everything. PayPal works with everything. It's a service of the network infrastructure. That, you're on eBay, you're going to use PayPal. You're on some odd website you found that sells some odd product you want to buy, you can use PayPal. It's like a universal concept, and so is the mapping works as an interface. In fact, more applications are using Google Maps and integrating them in as an API, which is great because it's always available on anything. So now we have, find a parking space apps. Actually, I used that the other day on my phone. It works. I was like shocked. I'm in a parking lot, and you press you open the app and say, "Find me a space." And it tells you where to go. You just follow the route. How does it figure it out? He's using some map, moving objects on a map. I don't know. Like space, looking at space orientation is what I'm thinking. Because it doesn't know who's parked there and who hasn't parked there. So it's finding holes in a grid is what it's doing. But it's using Google Maps, which is interesting. Okay, so applications themselves, cloud-based software that eliminates the need for the local infrastructure, such as Google Apps and Microsoft Online. So the cloud-based infrastructure in terms of the application, this is how we can get like Microsoft Office or something that's stored in the cloud that we just connect to and we use as a service. We don't have to install it on our local computer. It's an application that's in part of the structure. We have development in terms of the platform itself to build custom cloud applications. One of them, as an example, would be the Salesforce.com. It was a non-cloud that's turned into a cloud application recently. It's one of the first kind of forerunners. HP's got a couple of other product services that they've got haven't exposed yet. And there's a lot of development in this area, actually. The platform itself is referred to as the cloud-based platform, typically using virtualization servers such as Amazon, ECC, SunGrids, grid computing. Grid computing is taking a bunch of smaller mainframes, I shouldn't use that word, that's an outdated word, small systems, putting them together for combined power, combined storage, combined abilities. So it takes smaller chunks, puts them together in a grid or a solid block. Do we have a slight detour. Do we have the attendance thing going around? I've just noticed some people coming in. I don't know if we sent that out yet. My administrative break for today. Okay, now back to the lecture. So storage, terabytes, iDisks as a concept, which is going to be the Apple iDisk. Cloud-based storage, and then hosting the physical data centers, the call centers, such as run on IBM, HP, a couple of different companies that have hosting services. So basic cloud characteristics, the no need to know term. So we don't need to know the underlying details of the infrastructure. As I basically was mentioning earlier, it kind of takes us a step backwards because it hides. We have a lot of information hiding. We have a lot of encapsulation on the concept. In the old days, if we were doing this without this cloud concept, we would have to use utilities. We'd have to telnet. We'd have to ping something. We'd have to FTP and use all these different applications to access this network and to utilize the network. And the concept of the web browser, believe it or not, is part of that as well. So we don't need to know anymore. We just take, and this gives us the third generation. Most of you probably have heard of Web 2.0, maybe. This is Web 3.0 because we have a separation between the network and the local environment. So the internet now is just part of our local concept of communication, and we don't really think. In Web 3.0, there's no separation of the internet and appliances and utilities and tools. Now it's all together in one. In Web 2.0, we had internet-enabled devices, smart devices, phones and things that had internet capabilities. We could do voice over IP. We had intense gaming, virtual reality that was done through a network. 3.0 just takes everything away. It's all no more internet, essentially. The internet is part of our life. We walk around with the internet behind us. Kind of like the Verizon. That is Verizon, wireless. Where the guy walks around and he has the whole network behind him. Yeah, that's Verizon. Right. See, some of the marketing television commercials do work if they're done correctly. I still don't know who does the cloud, but okay. Point being that the network just follows us. It's with us. So we have a watch, might be synchronizing with a cloud or with a network. We have cell phones that might be part of this infrastructure, probably as well, because that's cheaper than data. It's cheaper than cellular service, the network, which is why now we have phones that actually do like Google Voice. You can set your cell phone to use an internet connection through the Google Cloud to essentially, provide cellular service. We have streaming audio, video over the internet. So why do we need cable companies anymore? Why do we? It's all basically converging into one network, and the seam between being online and offline is going away. So 3.0, there's no online, offline. Everybody's always online. So, which is, it kind of sounds futuristic, but it's tomorrow. It's today as well. It's turning into tomorrow overnight. Tomorrow comes very quickly, and it's practically here. We also have the flexibility and elasticity. We can grow, we can shrink, which is what that elasticity talks about, and flexibility. We don't, in the old days, you opened up it's like ITU. We're moving to a new building. They're laying network cable, or maybe they're not. They're probably not. They're probably going to go completely wireless, but they're still going to have to put in a wireless router and wireless. And, and you actually had to build the infrastructure in terms of the IT and the support. And we still have to put power outlets in. We still rely upon physically connecting something for power, for electricity. But the internet, we don't necessarily have to do that for. The internet is going to be around. It's going to be part of the appliance, part of the computer. It's not a separate component of it. So that's where you get the flexibility. So it allows these systems to scale up, scale down, utilize resources of all kinds, different types of CPU. You need more CPU power? No problem. Call us up. We'll upgrade your account. Okay, good. Well, this is what they do with the home service these days anyway. Load balancing. You're running a business that has its own cloud. You just, add another computer to it if you start growing. It's kind of like what Google does with their servers anyway. And it's the pay as much as you use and as much as you need. Prepay, pay as you go, buy an account, buy service quality, service levels. Let's say you're a low-tech person, you don't use computing that much. You don't have to pay with the same thing as a high-tech kind of person would. And it's always on. Anywhere, any place, you always have it. There's nothing to install as well. This is kind of the concept of our smartphones, actually. Clouds are transparent to users and applications, so now we won't be talking about applications anymore. We'll talk about utilities. And it can build multiple ways. Brand products, proprietary open source hardware, software, just off-the-shelf PCs, everything is part of the structure. So we build our clusters of PC servers, off-the-shelf components, plus open source software, combine everything, and put it all into one system software. Which leads us to believe, or leads me to believe, that we won't have this operating system concept anymore. Instead, we have hardware. We talk about a cell phone. It's a cell phone. Well, what does it have on here? Well, probably Android, actually. Most of the Android most of the phones have Android-enabled market right now. But we'll probably use Android. In fact, there's a new product out that's an Android-based PC system. You take the phone and you hook it to a docking station. It turns in Motorola Matrix. See that? Atrix, not Matrix. Atrix. Because it's all in one. It's a phone and a computer.
It actually has a dual core processor.
With a dual core processor. Can you put Microsoft products on there, like Office?
I didn't try it yet because it's been quite a couple of days since I
Oh, okay. Oh, you have one?
Yeah.
I've been dying to actually see it. Maybe we'll have to have show and tell one of these days. Or, I don't know, I'm too cheap to go out and buy it myself.
The problem with that was,
Yeah?
it's a touchscreen, right? So when you slide it off to allow the phone, that kind of takes a second.
Oh, okay, so it's not like the Blackberries when they did the wirelessly synced. If they could wirelessly sync that and not have any connection, that would be fantastic.
This one, internet is very fast.
Oh, it's a 4G probably. Yeah. Yeah, I have yet to use a experiment with a 4G network yet either. I'm still on a 3G. Haven't upgraded. Don't have a need for it, actually. I'm with Verizon, actually. Yeah. I used to be with AT&T. Before I taught the Android class, then I switched to Verizon. My Droid X. So I multitask. Okay, software as a service. And this probably, I'll cover software as a service and then we'll stop the lecture at this point. Well, unless you guys want more, we'll leave it up to you. Some of you guys just got here. Some of you have been here since for about an hour or so. But I got a little bit more I can give you. All right, so software as a service. It's a model for deployment where you have applications that are hosted by a service that are given to a customer. I've actually kind of explained that already in terms of the concept of the future of Microsoft Office. And it's generally referred to software rather than consumer software. Falls under Web 2.0. Software as a service is really a Web 2.0 because we know we're getting it. The line between it's online, offline, it's on the internet, it's not on the internet, is still there. We know we're getting it because we're subscribing to it. By removing the need to install and run the application on its own, we have the benefits. So we can have, as I mentioned before, a lot of those business benefits of being able to charge people who are actually using it instead of people copying it, things of that nature. And we have smaller commercial costs that are associated with it. We no longer have distribution costs. The concept of the shopping cart kind of goes away. Yeah. Actually, Web 3.0, I wonder if we will have shopping carts, actually. Because you can just have an account set up because it's just deducted every time you do stuff, perhaps. Although I wouldn't like that myself either. So it alleviates the burden of software maintenance and support and the control over the software versions and the requirements. Terms are used in terms of the platform as a service. So we have a PaaS instead of SaaS. So service as a software as a service, or we have platform as a service and infrastructure as a service, IaaS. It's kind of hard to say, kind of hard to write, and we're just seeing these buzzwords actually coming out. Not really used a lot because people are overwhelmed by acronyms to begin with. So virtualization that works in as a concept. So we have the virtual workspace, which I've actually kind of described all this already for you, and I'm giving you now the technical jargon that goes with it. This is what we're actually calling this concept. So we have this abstraction of the environment that's something that we can grow, shrink, that we can use. That's not part of our computer. It's the iDisk essentially, or the Mac. The disk that shows up. The drive that shows up that's not on your computer, but it's on the internet. So it's virtual. It's a virtual hard drive. Think about it. Implementation of the virtual machines. Well, that's actually kind of like what I'm doing here when I have Parallels as a virtual machine that runs Windows XP on top of operating systems like the Mac or something of that nature, where we have applications that run on top of applications, which I'm sort of thinking, I don't think it's going to run this way, but it would have been nice if that cell phone that you're talking about, the Atrix, has runs on Windows or something. Like you can take a Google Android, hook it up, and have your choice to run it with a computer that is supporting the Mac or that's supporting Windows as a virtual machine. And it's the underlying storage space, application holder that can kind of switch and transform into what it needs to be in terms of a virtual operating system. Virtual machine, which is pretty much the concept. So the abstraction of the physical host machine, is it a cell phone, is it a computer, and then the operating system also is an abstraction as well. Intercepting, emulating instructions, let's say from the underlying software. So we can have maybe a phone that has XP or the Mac on it, depending upon what we want, or a Unix system, and use it in different ways. So we're not relying upon now the concept of the hardware and the software. We're mixing and blending to create virtual machines, virtual environments. So provides an infrastructure API as well, plugins for hardware and software support. And down here we have this kind of old-fashioned hypervisor, where we have hardware, we have the virtual machine software, we have operating systems, and we have applications that are loaded on top of the operating systems. Kind of old-fashioned, actually. Been around for years. Currently, that's the way things are actually kind of working. We can actually kind of improve upon this in the future, I believe. That's just what I'm saying. So in terms of the virtual machine, what we're talking about is the technology that allows this. So we have a guest operating system, let's say a Linux, a NetBIOS, a Windows system that's on top of virtual machines, that's on top of the software, that's on top of the hardware. So we add layers of abstraction to all of this. And depending on how we design the layers, we can actually really customize the computing platform for whatever user. So you can basically use the same hardware and have different things. In fact, that's kind of the concept, sort of like what the iPad was envisioned to begin with, which hasn't really turned into this, but the cell phone slash computer slash tablet slash all-in-one computing platform that gave you all of these different capabilities. I'm not quite sure that the iPad is small enough yet to fit in your back pocket or jacket pocket to actually carry it around as a cell phone.
I think if it's reduced to that single size, maybe it can be converted.
I saw a prototype that is, I don't know, it was rumored to be an Apple prototype. It was on YouTube for like 5 minutes and then it went off. Like they removed it immediately. It was a folding tablet. Yeah. That was super thin. That folded out and the whole screen became one solid screen. But it had like pieces that it like had 3 pieces to it. It came out like 2 this way, 1 this way, and it turned into a tablet. And when you folded it up, it was like the size of an iPhone. It was like really thin. And it was a phone that turned into a tablet. Yeah. Now, it was on YouTube for 5 minutes, and then disappeared. So, either it was somebody's proprietary idea they were testing. Oh, yeah, let's just put it on YouTube, show it to the investors. Oh, no, don't do that. Somebody made a mistake with that one, but I looked at that and went, what? I played like 5, and then I went back and I'm like, you gotta check this out, and it was gone. I was like, man, you gotta check this out. But that is not to leak the idea even further, but that's a really cool idea. Because it takes and gives you the tablet with a big screen. I mean, the problem like with some of these cell phones now, they're so big, but we want the big screen. So how do you get it? You fold it out now. But this one had, and they got to improve it. They have to totally improve it. You could see the lines because there was a metal wrapping that went around to hold each one of the components together. And I don't know why they chose a three design on it, because you had 1, 2, and then you had another one that folded over. So it looked weird. It didn't actually kind of come together correctly because they had to push it. They folded it out and then they pushed it. So it was actually kind of like a half dome, not really a square. It was kind of weird. But it was, if they can get rid of it, just make it glass on the end so the glass fits together. And then you could probably, with the graphics capability, you could probably get rid of the lines and the seams. So when you looked at it, it looked like a full picture. That, I believe, is going to be the future, but we'll see. I don't know. It seems really expensive for that to work. You got to make them really thin. But now the iPad is really thin. Now the newer iPad 2 is thin. They make it a little bit thinner, make it fold. Then you got a product that's a cell phone, a computer, and a tablet all in one. I don't know. We'll see. I'm waiting for that video to come back. So, I don't think it's going to come back. It was a prototype, and they were demonstrating the prototype. But yeah, that was a mistake. The purpose of the bet, actually, it was on a tech channel too. Somebody else caught it and they recorded. They tried to record it. They tried to copy it, but it was there for 5 minutes, huh?
They'll probably ask you to move that.
Yeah, it was like somebody's mistake. Somebody leaked it. I hope it was an accident. It wasn't somebody trying to show the idea. But now it has me thinking actually about different products, different ideas for that. But, because you know they have the ones with the keyboards, the virtual tap keyboard. So the item projects through a camera, it projects out a keyboard on a tabletop, and you use it. So you don't have to carry a keyboard around. That technology is already in development. Because the concept of, you don't want to carry the keyboard. So, yeah, you can do a Bluetooth keyboard with an iPad or with a Google, whatever, tablet, but you have to carry it. If you're going to carry all that stuff around with you, you might as well just carry the computer, right? So make it virtual. Make it so it shines on a surface or it's a piece of paper. You roll the paper out and you type on the paper, and it connects. So, all right. Well, that was a slight tangent, I would say, but it's probably a good stopping point actually for today because I think I'm losing a couple people already. So, all right. So next week we will continue. It looks like we're going to get interrupted as well. We will continue with cloud computing. I have more to say about this. If you're interested, it is lecture number 17. It's the last one that was just added. If you came in late, I put out, and actually, because most of you are sitting here came in late, so I'll just briefly go through it again for your benefit. On bhacker.com, I put out the midterm exam, and I also put out the, I thought I had this up. I think I closed it. It's going to be in the main screen, actually, when you get in here. So here we go, Strategic Management Information Technology. The midterm exam, which is going to be due in a month from the 17th. So it's April 7th, this is March, April 17th, the weekend right after taxes are due, if you remember that, will be the deadline for it. And I also put out the CSLO essay. If you're familiar with that, it's a totally different essay than what we've had in previous terms. And the midterm, just a few little notes about that, and then I'll talk about the, I'm not going to repeat everything I said earlier, but I'll just give you a rundown on it. The midterm is a significant portion, it's 20 points. It is answering, and you need to answer all 10 questions or 2 points each. You don't have to provide a novel. If you provide a paragraph, 100 words, 50 to 100 words, it's probably going to be enough. But you might also find that some of the questions are going to lend themselves to more words than others. You don't have to answer them all in the same length, but I said a paragraph or two. Don't write a novel for each one of them. You get the same points if you write a paragraph or two versus 12 pages for one question. And it's simply answering 10 questions, and it basically runs through everything we've covered so far in the course up to the midterm. And the CSLO essay is actually kind of interesting. It's a new format that I've put together. It's not like anything you've ever experienced before in the past in terms of the CSLO. It is an essay that you're writing that is 3 to 5 pages in length. One essay on one topic. There's 5 selections. And I've actually already gone through it, so I'm not going to repeat all that stuff. You can watch the video. But the focus of this now is to write one essay on your selection, one of the 5. And you're providing 3 reference citations, which means you need to do some research. And this is really a research paper. And it needs to be in a formal writing. You're being graded on your style and on your presentation and on your writing abilities. Because this is a graduate level course, and you guys all need practice. From looking at previous CSLOs from previous terms, you guys all need practice. It's been, even in the faces have changed, the people have changed, but it's all the same. You guys still need practice. All right, so what you're doing here is you're providing at least 3 reference citations. This 3 to 5 pages is double spaced, so it's really a page and a half single space. Think about it, at the minimum. You're writing it in your own words. We are going to take all of the papers and we're going to process it through Turnitin.com, which is a plagiarism checker tool. And we are also going to do some other plagiarism checks on it, some internet checks. If your paper comes back and it has been plagiarized to a certain percentage, above 40%, so which is kind of the arbitrary number I've decided on, you're going to get 0 credit on the assignment, which means you can't do it again. It's worth 20 points, so it's going to give you a B- in the course automatically. No opportunity for a grade change or a redo on that. So you get 80 points, 80%, which is a B-, if you've done excellent on all of the other work that you've turned in so far, assuming you've turned in the rest of the work. So this is really going to be a grade changer for some, I would suspect, because some people aren't going to listen to me, they're not going to watch the video, and they're not going to know that they can't just recycle somebody else's paper, or 5 people can't turn in the same paper. One person has to turn in your own original writing. Can't be cut and pasted from the internet. It can't be, and it's your opportunity to practice your English writing skills in an academic level. And if you're concerned about the format, you don't know of one, you can use the APA format. You go to apa.org, A as in apple, P as in Paul, A as in apple, and American Psychological Association. Or you can use the MLA, Little Brown Book, any one that you might be familiar with. You're not stuck with that. You can choose your own. But I mean, I'm not going to actually nitpick the format. What I don't want you to do is give me a reference citation that's just a URL. You know, the author's last name, first name, the date, where you got it from, reference date, stuff like that. Real, you know, like a true academic type of effort. Because this will help you, especially if you go into writing any journal articles or publications of any sort. It's not a bad idea to be able to actually express yourself in English in a written formal paper. And then at the same time, you're demonstrating, hopefully, that you've understood one of these 5 different concepts that we've gone through. The CSLO essay is not due until the very last day of the course, until the final exam, which will be the last week of April or the first week in May. I'm thinking that the last week of April is probably going to be when the final exams occur, and then all of the assignments will be due like May 9th or something like that. So, probably going to be the case. Any questions on the CSLO essay or on the midterm? The midterm is not due at the end of the course. The midterm is going to be due in a month from now. And the TAs will be bombarding your email accounts with messages and reminders and warnings as soon as they get everything updated. So I think probably after this week, probably send out a message as a little reminder for people who aren't watching the videos, who don't show up, who aren't going to know what's going on, that there is a deadline, there's a due date on that midterm. And I'll finish cloud computing next time. Any other questions, concerns, comments? Nope. Okay, then we're all done for today. Enjoy the rainy weather we're having.